Now, let's apply what we've learned about end behavior to a specific type of function, polynomial functions. We are looking at the function of the form f of x equals k times x to the n, where k is a constant and n is the positive integer. The end behavior of a polynomial depends on two things. First, the degree, whether it's even or odd. Second, the leading coefficient, whether it's positive or negative. Let's go through all possible situations. Case 1, when we have even degree with positive constant. For example, x squared, x to the fourth, x to the sixth, and so on. As x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches infinity. So both ends go up. Case 2, when we have even degree with negative coefficient. For example, negative x squared, negative x to the fourth, negative x to the sixth, and so on. As x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x also approaches negative infinity. So both ends go down. Case 3, when we have odd degree with positive constant. For example, x to the third, x to the fifth, x to the seventh, and so on. As x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches negative infinity. So left goes down, right goes up. Case 4, when we have odd degree with negative coefficient. For example, negative x to the third, negative x to the fifth, negative x to the seventh, and so on. As x approaches negative infinity, f of x approaches infinity. And as x approaches infinity, f of x approaches negative infinity. So left goes up and right goes down. Now that we understand all the cases, let's apply this to an example. We're given f of x equals negative 3 times x to the fourth, and we want to find the limit of f of x as x approaches infinity and the limit of f of x as x approaches negative infinity. F of x is a polynomial with an even degree and negative coefficient. So let's go back to these 4 cases. We want to look at the end behavior of even degree and negative coefficient. As x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. So the limit of f of x as x approaches infinity is negative infinity. And the limit as x approaches negative infinity of f of x is also negative infinity. So the graph of f of x equals negative 3 times x to the fourth will look similar to this graph, with both ends going downward. It looks like an upside down U shape.